Hi, this is Larry. You asked for a pic, and here is the picture of all the information in this story. I'm going to talk you through it. I want you to work on drawing your own version of this point by point as we talk through it. So don't let it bother you right now that there's all these numbers all over. We're going to talk through it one at a time. I prepared this in advance because it's a lot of stuff. I didn't want to draw it as I was talking about it. So the first thing is fire tower A is 52 degrees north, 52 degrees west from tower B. Now that kind of direction, 50 north, 52 west, means that we start from tower B, like the phrase says, from tower B. We look due north, which is that green line. The green lines are the directions north and east. So we start at tower B, we look due north, and then we rotate toward the west, which is counterclockwise, 52 degrees. And we see tower A 80 miles away. So this angle right here, that 52-degree angles, that's because tower A is north 52 west from tower B. Okay? So that's the first angle on your drawing. You should draw from due north from tower B, and then 52 degrees west of due north. Draw a line to tower A, label tower A, and it's 80 miles between tower A and tower B. In the end, all we're going to want is that triangle between tower A, tower B, and the fire. And when we have that triangle and we know the angles of that triangle, we can solve the triangle. But for now, we're starting with that 52-degree angle. Then we have two towers 80 miles apart. Everyone spots a fire. From tower A, the fire is 117 degrees. That means this kind of navigation angle, starting from due north, we rotate clockwise 117 degrees, and we find the sight line from tower A to the fire. So you'll see right here, the 117-degree angle between due north and the sight line between tower A and the fire. So label that 117-degree angle. And then we also know that the angle between due east and the sight line between tower A and the fire is 27 degrees, because the angle between north and east is, of course, 90 degrees. Add 27 more, and we get to the 120, we get to 117. So this, we also know, this 27. So now on our chart, we've written the 52 and the 27 and the 117, and let's go from there. Okay, so those are all the angles written in green. Now we'll get to the other ones. Oh, also 340 degrees from tower B. That means starting at tower B, looking due north, we rotate clockwise 340 degrees, which is the same thing as rotating counterclockwise 20 degrees, because 360 minus 340 is 20. So you also see this 20-degree angle. Let me mark it here. This 20-degree angle. Now we put that on our chart too. So we have all the angles listed in green, and we have that 20-degree angle. Now we can start to figure things out. We want to know the angle up, the triangle that we're interested in. Let me get a good color here. Oh, no, we can do it with this. This is the triangle we're interested in. We want to figure out the angles of that triangle. Well, let's start with down here on lower right. We know that the whole angle from due north to the line AB is 52 degrees. We know that that small angle is 20 degrees. Therefore, we know that this angle in our triangle of interest, this angle has to be 32 degrees, 52 minus 20. Now, if you look for a minute at this larger right triangle, we have the angle 52 degrees is the lower right acute angle of that triangle. Therefore, this angle has to be 38 degrees. 90 minus 52 is 38. So now we know that the whole angle from here to here is 38. We subtract the 27, we get that this angle of our right triangle, let me clear up all this mess here. Okay, so with all of that, we get that this angle of our triangle of interest is 11 degrees. We know that this angle is 32 degrees. We figure out then 180 minus each of those. This one is 137. We check our work. 137 plus 32 is 169. Plus 11 is 180. So those are the three angles of this triangle of interest. And this one side of 80 miles will allow us to solve this triangle with the law of sines. Sine of 137 over 80 equals sine 11 over the length FB, which is the fire to fire station B. That's actually what we're interested in whichever one is shorter, but we're going to figure out both of them. That also equals the sine of 30 degrees over the line AF. So we can solve for each of those sides with the law of sines. Just to answer that first question, though, without doing all this figuring, we know that the smallest side of a triangle is across from the smallest angle. Therefore, the smallest side of the triangle ABF must be the side opposite the 11 degrees, which is the side from fire station B, tower B, to the fire. That must be the shortest distance, and that's what we want. The tower that's closer to the fire must be fire tower B, and we can solve for that with this. And if we want to know the other distance too, that's that. And there you go. It's a lot of stuff. I hope I've talked you through it start to finish. The key thing in all these problems is to be able to carefully draw a drawing and then figure out what you can about all the angles. So I'm going to follow this question, and if you have a question or comment for me, leave it here, and I'll see it. Goodbye.